Hello, good morning. It's the 2nd of January. It's about 6 o'clock in the morning, and I'm here recording this video so we can, so I can explain Bernoulli's principle. I got my jacket on right now because it's kind of cold outside. So, because I'm here early making this for you. Okay, so we'll just make this video about Bernoulli's principle. This is a follow-up to Newton's three laws of motion, and this is also the follow-up to the four forces of flight. So if you haven't reviewed those yet, I would go ahead and review them right now. But okay, so Bernoulli's principle basically states that for a certain fluid, its velocity is going to be constant with its pressure as it flows through a system. And then as the velocity increases, your pressure is going to decrease. Okay, so basically it states that for an increase in velocity of a fluid, your pressure is going to decrease. So we'll go ahead and put that in your memory right now. Velocity increase, velocity up, pressure decrease. So pressure decrease. So there we go. So remember, velocity up, pressure down. Velocity up, pressure down. That's about the gist of it. Bernoulli's principle can probably be explained in more detail from other videos, but here is the FAA instructor method of explaining it. Bernoulli's principle, you'll see drawings, and basically the drawings that they use to describe it is that you'll take a tube right here. So let's say we had a tube right there. And then in this tube, you had some type of a fluid. So we'll go ahead and draw, in this example, we'll go and draw water. And water is a good example because water is actually, you can't compress water. You can compress air. So there's a compressibility factor if you start talking about air in a, enclosed system as far as pressure is concerned. So water is a good example. And let's say water is flowing in this direction. So we'll draw another vector area. I'll do peach since that's a good color. Okay, so water is flowing in this direction in this enclosed tube. Now, if we were to put gauges on this tube, let's say we were to put a gauge here, a gauge here, and a gauge here. Now, let's say that these gauges measure two values, which you got it, is velocity, and then you got pressure. You got velocity, and then you got pressure. And then you got velocity, and then you got pressure. Okay, so then what's going to end up happening is that this is going to show that your velocity is going to be constant with your pressure until you put a constriction in the pipe, which in this case, we'll put the constriction right there. Okay, so there you go. So now you got a constriction. And what does this mean? Well, what ends up happening is the fluid has to start here and end there. And the same amount of fluid that starts here has to end up here. You don't have a bottleneck, if you will, or you don't have a backup of fluid. That just doesn't happen in the system. Well, it does, but in this example, what they're trying to impress is that the same amount of fluid here is going to end up here. So in order to get through this restriction, the velocity of the fluid is going to have to increase because you have more of it trying to get through a smaller space. So what you're going to have is you're going to have an increase in velocity. So we'll put an increase there with a corresponding drop in pressure. So we'll put a negative for the pressure. So here you're going to have a certain value, which is going to be equal to each other. Or actually that should be equal signs. You're going to have a certain value which is going to be equal to each other. So here we go. So we'll put the little equal signs. So those values are going to be equal to each other. And, those values can be whatever they are. They're what we're trying to impress on you. And I'm not trying to come up with I'm not going to come up with arbitrary numbers and get you confused and put like a 5 or a 10 because there's no significance to the meaning with 5 or 10. Instead, what I'm going to do is I'm just going to put some equal signs, understanding that in this case, for a set value V, you're going to have a set value for P. And then in this case, for a set value of V, you're going to have another set value for P. And all you're going to have to understand is that in this constriction right here, your velocity is going to go up and you're going to have a corresponding decrease in your pressure value. That is essentially Bernoulli's principle. That is what that explains. As a private pilot, that's the extent of that you'll be required to explain it. Now, there's other factors. Now, the reason we discuss Bernoulli's principle is because in aviation terms, it ties in a lot with the concept of lift. Actually, it pretty much explains the concept of lift. Well, one of the theories of lift goes into this. Primarily, you got Newton's third law of motion, or second law of motion, which is force is equal to change of momentum for change of time. For a constant mass, force equals mass times acceleration. And then, of course, there's also for an action, there's an equal and opposite reaction. Um, there's a lot that goes into this. This is a very, very broad paintbrush stroke of Bernoulli's principle, but I think that right now you'll have a pretty good understanding that this is what this is supposed to explain. So, okay, in my next video, I'll go ahead and explain the lift equation, and then we'll just go from there. If you have any questions, let me know.